It's Reality Check with Craig Price.
I'm an idiot.
4 minutes in and I'm already wrong.
I'm like a monkey. Hello, look at me. Hey, I need you guys to do these things.
This whole show is a tangent.
Cool. That's why I dig it.
Shazam!
It's Reality Check with Craig Price. This week, meteorologist Steve Lanore returns to talk about his new book about tornadoes. Welcome to the podcast. Hope things are going well. Before we start, a quick reminder that you can download the free app, which allows you to listen to the podcast. You can download your favorite episodes for offline listening, and there's a lot of extra goodies like full book PDFs, sample chapters, teleseminars, and more, including a preview of today's guest book, Twister Tales: Unraveling Tornado Myths. Head over to iTunes, Google Play, or Amazon and download it today. Now, I've been pretty lucky weather-wise. I've lived through some blizzards, a couple of hurricanes, but that's about it. And tornadoes seem to be all over the news, and you know it's in the American psyche when they have a bunch of movies about them. You know, those same movies perpetuate a lot of wrong ideas about what tornadoes do and how to be safe when you're in one, but thankfully, Steve's written a book that will help you figure out what's true and what's myth. He's a true working meteorologist, and he's back again after we talked to him on episode 71. So let's talk about Twister Tales: Unraveling Tornado Myths with Steve Lanore. I've lived in Houston probably for 20 years, not 20 solid, about 15 out of 20 years. And I know we're at the very end of Tornado Alley, so to speak, but I have never firsthand seen a tornado. Can you kind of tell me, what conditions are necessary for tornadoes to exist? Because I have heard about them in the area, yet I have never seen them.
Well, one of the reasons we don't get too many down in Houston way is because one of the big things you need for tornadoes is called wind shear. I want you to imagine that you're on a ladder 5,000 feet high into the atmosphere. So you got really strong legs, and you're going to climb all the way to the top of this baby. So you start at the ground, and you got your little nerd anemometer, and it tells you the wind is blowing 20 miles an hour out of the south. Now you climb all the way to the top, and you get out your anemometer, and it says the wind is 40 miles an hour out of the south. That's called wind shear. It's a change of wind speed or direction with height, and that causes a big rolling motion in the atmosphere, and that's very essential to try to get the air to spin. So if you don't have that a lot of the time, which we don't get that often down around Houston, you'll have a lot of wind, but it's all kind of blowing at the same speed, and you just don't get the turning necessary for the big tornadoes. Now, you can get a lot of little ones off sea breeze fronts, or when hurricanes come in, you can get some, but the big ones are going to be farther north where we have that wind shear that really can kick through, like North Texas, Oklahoma, on up into Nebraska.
Well, what causes that shear? I mean, because as far as I'm not a native Texan, and so except for the fact that we have swamp in Houston, when I go to Dallas, it's very similar to me, except the humidity's less. So it's just a matter of, water in the air. What causes wind shear in general?
Well, the jet stream, which blows along between about 20 and 30,000 feet, drives a lot of the systems like fronts and things across the country. Wind shear is a combination of a couple of things. It's the jet stream momentum feeding down to the lower atmosphere. It's also caused by a pressure gradient. So if you have a big area of high pressure over you, you have very weak winds because all the pressures are kind of the same. If you were to drive from, say, Beaumont to Houston and the pressure was the same on your barometer, that'd be a very weak pressure gradient. You don't get much wind when you have a weak pressure gradient. But now if you were to drive from Dallas to Oklahoma City, let's say, and you notice a big drop in the barometric pressure, now you have a strong pressure gradient, and the wind is going to speed up in response to that. Think of a hurricane. If you notice on the maps when a hurricane's on there, there's a whole bunch of black lines close together. Those are the isobars. That's the barometric pressure at each point in there. And when there's a huge change horizontally, like you're driving, that causes a lot of wind. We tend to get more of that farther north where the lows and highs are stronger. So that is a big element in wind shear, and the jet stream is the other one.
So is it certain times of year that you're going to be more likely to get tornadoes, or is it just when you get certain fronts coming through?
Well, things amp up in the spring because that's when you have your really big temperature contrast. The atmosphere is still very cold up around 18 or 20,000 feet, and you get these fronts coming down and these what we call upper-level lows, a trough of low pressure, a big pocket of cold air up there. And when you put cold air on top of warm air that's starting to show up in the spring, you get a very unstable environment. Think of a pan on the stove. You turn the fire on, don't touch it, it's hot, and it starts to bubble the water up. Those little bubbles of water coming up are being heated from below and rising through the cooler water around them. It's the same thing that happens in the atmosphere. So the more you heat the bottom and cool the top, the more you're going to get this overturning effect that makes the air want to rise into storms if you have enough moisture. So that's kind of maxed out in the spring between mid-March and mid-June. And then we have a second weaker season in the fall when everything kind of reverses. But in the spring, you have a biggest contrast between cold air aloft and warm air at the surface, and you have that wind shear kind of maximized too. And that's why, like, a lot of the big tornadoes historically have been in April and May.
Is that where that polar vortex that they were all talking about this last winter may actually come into effect to some degree?
Well, the polar vortex a lot of times will shut down the tornadoes a little bit because there's too much cool, dry air down at the ground. So it can cause a lot of bad weather on its edges, like Nebraska and Iowa really got hammered back in June with some big tornadoes. But underneath the vortex itself, like over in Michigan and New York, there was one little episode, but their weather was actually quite cool and not as stormy as usual because it didn't have the heat at the ground. But that baby is definitely going to be an issue this winter, but that's a whole different conversation.
Well, my guest today, if you probably recognize the voice, is Steve Lanore, our favorite weather guy. He's got a new book out called Twister Tales, Unraveling Tornado Myths. And this book is all about tornadoes and a lot of the myths that come along with them. And I know the biggest myth that I thought was true until I read your book was because I've never been in a tornado, was the green sky situation. I used to teach defensive driving for the state of Texas. And there's a section on weather and how to drive in weather. And I would always open it up to questions, and people would ask me about tornadoes, which I didn't really have that much information on. So I would often refer to other people in the class who had been in there. And a lot of people would say, when the sky turns green, you know a tornado is going to be coming. Now, this apparently is not true. So where did that come from?
Well, it's a good question, Craig. In fact, that's the first myth in the book, is to debunk this idea. Well, it's kind of like a lot of things. People have selective recall. You see a guy on television, I was sitting out back on the porch having a beer, and all of a sudden the sky turned green. I knew a tornado was coming. Or he could have some other accent.
No, that was pretty accurate. I think that one was pretty accurate.
we get a soundbite on the news from that, and we think, oh, okay, the sky was green, a tornado hit, so therefore that works. But then what about the 20 other people that were in other parts of that storm that didn't see a green sky and still had that tornado hit? So I think that's part of it. Also, there is a study, and I quote a couple of these in my book. There are several studies by different people that have gone out and done field research or, gone through many storm reports and read the reports from that green skies can often be associated with strong storms. What happens is the sun is setting a lot of times when your storms are at their peak between 5 and 8 o'clock. The sun's getting low in the sky, and from just looking at sunsets that they'll tend to be orange or red because of the way that light is scattered by the atmosphere. So let's take a red sky, let's say it's 7:30, 8 o'clock at night on an April evening, which would be near sunset, and then we add a storm to that with a 10-mile-high cumulonimbus cloud, really, and dark black or gray cloud. So that mixes with the red light and creates kind of a greenish light. And it's the result of those two things mixing together. Also, very high humidity in the atmosphere. That moisture in the atmosphere can create kind of a hazy look. So the report is you get a green, hazy look to the sky. And then if a tornado comes, you make that association. But it might just be a bad storm. You might get some heavy rain, or you might get hail, or you might get a tornado. But it's a terrible forecast tool to say, oh, the sky is green, we're going to get a tornado. Here's what you need to do is, first of all, I would encourage you to download an app on your mobile phone from your favorite TV station, or they have National Weather Service apps you can download. There's all kinds of free apps you can get to look at radar and stuff. So now you'll have some real information. You see a bad storm coming, let's find out what's in there. You can guess, or B, you can get some technology to tell you what's really in that sucker. And that's a lot better than looking at a green sky. So the reason this is a myth is because it's unreliable. A myth doesn't have to be false 100% of the time to be a myth. In science, if something's not reliable and reproducible, then it's worthless.
So it sounds like you don't need a green sky to create a tornado or have a tornado, but if there is a green sky, the odds are it's going to be some bad weather of some type.
Right. That's perfect. And in fact, on the cover of my book, you see a tornado that is just a gray and black sort of a sky. There's nothing green there. And if you look at famous storm chaser videos of like the Moore tornado from last year up in Oklahoma City, there's a big tornado that went through Hattiesburg, Mississippi a couple of years ago. the Wichita Falls tornado, 1979. I can go on here, but I fear to begin to bore you. So the skies weren't green in any of those. It's just another myth that it's kind of like that myth. I don't know if you've heard it. Every year in August, you hear this myth that Mars is going to be as big as the moon. That myth won't die, and that thing's been out for 10 years on the internet. It's just not true. So it's the same kind of thing. It just kind of gets recirculated over and over again. And that's one of the points of my book, is to try to put these things to bed and say, here's why they're not true. Not talking down to people that believe it, but just using the science to say, well, here's why that doesn't really work.
Well, they've got all these researchers out there. They've got the storm chasers. These, quite frankly, the ones we see there are the ones that just seem to be like thrill seekers in these Mad Max vehicles, chasing down their own demise. And what kind of research are they doing? Because is tornado detection getting better, or is it still kind of, as soon as they see something, that's when they tell everybody?
Well, let's be honest. I've got several friends who are storm chasers, and I've done it myself. Part of it's just the thrill of the
I knew it.
And the excitement and the intensity. But a lot of these people do actually report these back to the National Weather Service, or there are guys out there that have measuring tools. Of course, there's the famous DOW, the Doppler on wheels, but that's one university doing that. A few of them. I think Texas Tech's got one. Of course, OU's got one. But the big thing is reporting the information to the National Weather Service or law enforcement. Because here's the problem. We have Doppler radar, which is great. It looks out there. You see the hook echo, and that tells you there's a strong rotation in the storm. That does not tell you if it's on the ground. And this is another myth I address in my book, is that a hook echo on radar tells you that, hey, there's a potential for a tornado in there. It does not confirm it on the ground most of the time. So those spotters, those chasers, often will be the front guard, if you will, that, hey, this actually is on the ground. And that's very important, because if people know it's on the ground, I think it just raises their level of alertness beyond, it's just a funnel cloud. People kind of dismiss it if it's not on the ground. So that reinforces the emergency to have that out there. And those guys are, a lot of them, drive hundreds of miles, use a lot of gas, and they get nothing for it but the satisfaction of trying to warn the public.
Well, how much technology has advanced in the last 15 or 20 years? Because, they've gotten to the point where they can show us where lightning is striking, as where it's hit the ground. I mean, I'll see the weather here in Houston, and they'll throw it up there, and it'll be covered in these little dots where they say, well, this is where the lightning's striking. If they can do that, can't they kind of figure out more accurately what's going on with tornadoes yet?
Well, the frustration is because the Earth's curved and radar beam goes straight, the farther and farther you get out from the radar site, the higher that beam is slicing through the storm. Now, the tornado comes out of the bottom, of course, and it's touching the ground. That rotation from that tornado goes way up inside that cloud, 20 or 30,000 feet. So what the Doppler is going to show you, let's say you're 75 miles from the nearest National Weather Service Doppler, and you have a tornadic storm approaching you. The radar is looking through that storm at about 8,000 feet. So it's not seeing the tornado in the bottom. It's seeing the rotation associated with the whole storm. So then there's a little bit of guesswork involved as to whether or not that's actually on the ground. Now, the way they do it is there's a threshold value of speed. When the wind starts spinning beyond a certain number, then they have a pretty good idea it's probably on the ground. But I've seen storms that had, let's say, 100 miles per hour of wind shear. It's 50 miles an hour one way and 50 miles an hour the other for 100 total spin. And that usually would be considered strong enough to have a tornado on the ground. But there was no tornado. They had a spotter there, and he said, all we see is a rotating wall cloud, and it never touched down. So there's the frustration with the radars because of the beam going higher and higher the farther away you get. And this is, again, where these spotters, which a lot of times the storm is pretty far from the radar site, can really say, hey, here's what we see, and we're watching it, but no, it's not on the ground yet. And the more information we gather like that over the years, Craig, the better we can predict the next one. I mean, it's going to take a long, long time to ever be able to say a tornado is going to show up in a half hour in southwest Houston. I don't know if we'll ever get to that, but we can definitely get to the point where we say this storm has the potential to produce a tornado. And in fact, we're going to be going to a probability forecast here in the next few years where if there's a storm out there with a tornadic circulation, they may issue a probability. There's a 60% chance this will produce a tornado in the next 20 minutes or something like that. So we're headed that way. It's never going to be 100%, but all this information that's being gathered does factor into a greater understanding of what's going on in there.
Is that why the tornado warnings often don't really amount to much, because they put them out all the time? I mean, like I said, I've lived in Houston quite a bit, and I hear about them all the time. And now thanks to our cell phones, you'll be halfway asleep at night, and things will go off in the middle of the night as they warn us of a tornado warning. But nothing. Then you watch the news the next day, and nothing really happened. And so is the false alarm rate getting any better, or is it?
Well, you'd be surprised, and I'm sure your listeners will be too, to learn that the tornado warning false alarm rate from a recent National Weather Service study is 70%. Now, that sounds terrible until I tell you a little more about it. The big tornadoes, the ones that do most of the killing, the warning rate on those is the false alarm rate on those is much lower. It goes back to this whole idea of finding that wind shear inside that storm with the Doppler radar. When a very large tornado is forming or already on the ground, the signature on that is almost unmistakable that it's going to be on the ground. In fact, they've got a new thing now with the newest National Weather Service. They call dual polarization radars, and not to get off too much into a PhD discussion here, but basically there's a new type of interpretive process in there and a new type of radar beam that allows them to actually see the debris the tornado is throwing into the air. So if we have a significant tornado hoisting debris up into the air, they're going to see that signature on the radar and have very high confidence it is touching the ground. Now, it's the smaller tornadoes that cause this high false alarm rate, especially down around the coast there, where you get these little spin-up water spouts, these little bitty EF0 tornadoes, winds are 60 or 70 miles an hour, and they last 30 seconds. Well, the Doppler scan takes several minutes to go around 360 degrees. That baby's going to form and die before it even has a chance to be warned on. And that's where a lot of these false alarms come from. The big tornadoes, the Moore tornado, the ones that hit up there in Joplin, the ones that hit Tuscaloosa back in 2011, all those had a lot of advance warning because they were large. And so the good news is the killer tornadoes have a much lower false alarm rate. In fact, I would say it would be almost impossible for an EF3 or an EF4 to go through some place without there being a warning on it first.
Well, let's talk about this debris because, I can see how if a tornado comes on and because wind knocks things down. We've seen that happen. Even if you just have a fence and a strong breeze, you can understand the concept of wind knocking things down and breaking it up. So having a building get knocked down and having pieces fly around makes sense. But, you watch movies and it's usually a herd of cows and a tractor trailer being shot up into the air that weighs several hundred pounds. How much can a tornado actually pick up? I mean, I can see, like I said, a building can be destroyed into little pieces and all that debris sent everywhere, but you really can't, wind is not going to blow up a cow and send it in little smaller, lightweight pieces. So what can it lift up?
Well, Craig, you might be surprised to know, and if folks out there have seen the movie Into the Storm, it's pretty good Hollywood drama, but there was a lot of meteorological, I call it meteorological murder. There was a lot of mistakes in that movie.
Are you trying to say that Hollywood is not scientifically correct?
Oh, I know this is a shock to people. I hope you're seated. but to answer the question there, large pieces can be picked up. In fact, in my book, I mentioned that a 10-ton storage tank was thrown a half mile in the Moore tornado last year. Now, that one had about 200-mile-per-hour winds. You get winds up over 150, you really start getting some extreme things happen that just don't seem natural. So cows can be picked up by tornadoes. I mean, semi-trucks, entire 18-wheelers have been picked up by them and thrown several hundred feet. Naturally, the heavier the object is, the less likely to be thrown very far. But there were 3 storm chasers killed last year in the El Reno, Oklahoma tornado. Their car was thrown 500 feet. They did a study on that and figured out where they were and where they wound up. And, of course, the vehicle was crushed and they were killed in that. Very tragic. So, yeah, things can be thrown a considerable distance. They did a study back in the 90s on several tornadoes in North Texas, and, of course, lighter objects can go farther. They found personal items like checks and smaller, lightweight things like that 200 miles from the storm. They found moderately heavy objects like bricks and wallets and things that weigh between a few ounces and a few pounds thrown up to 5 miles away. 1953, a tornado went through Worcester, Massachusetts, picked up a piece of aluminum roofing and threw it 20 miles. So, yeah, stuff can go a long way in a big storm.
Well, then that leads me to the most obvious question. How possible is Sharknado?
Well, I think we need to go back to the Hollywood topic to kind of answer that.
Because isn't that basically just a water spout that has gone much farther than it possibly could on land?
Oh, yeah. I mean, water spouts, when they cross the beach, become tornadoes. That's really the definition of it. And that's another myth in my book. Nice segue there. Thank you. we have a myth about waterspouts that they're not dangerous. Well, there are two kinds of waterspouts. There's the garden variety waterspout that just forms out there when it's not even raining, and that one's really not that bad. I mean, it can cause a hazard to boaters, and it can come ashore and generate a wind of about 40 or 50 miles per hour, which is not going to be fun. That's not really going to be a deadly situation. Then we have the waterspouts that form from tornadic thunderstorms. It's the same kind of storm that would form in northern Texas, but now it's down farther south. So if you have a tornado watch in Houston or Galveston or Corpus Christi or Florida, wherever you're listening from, that means that those type of waterspouts could form, and those are basically just tornadoes over water. Those are the dangerous ones. There's a great picture in my book of a 1997 tornado that hit Miami. It formed over the city and moved right out over the water. You can see sparks coming out from the electric if you go and search the YouTube link I have on there, and it did quite a bit of damage. It was not a waterspout like the garden variety, hey, not so bad ones. It was a tornadic waterspout, which basically is just a tornado over water. So there are two different kinds and two different levels of emergency there now on that.
Now, I've heard of, a tornado like hitting a small pond and taking a lot of the water out of that. Is that something that you've heard of as well? Is that a myth, or is that an actual possibility?
Oh, if it's small enough and the tornado's moving slow enough, sure, that could happen. I've never heard about one being drained completely, but if you're talking about a stock tank, something that's 30 or 40 feet across, that's certainly possible. I wouldn't think a multi-acre pond would have that happen to it. But, yeah, it's picking up water, and a big tornado is going to pick it up at the rate of several thousand gallons a minute at least, and maybe even a second, depending on the size of it. So, yeah, that certainly is possible. I haven't actually read of that myself, but there's a lot of freak things that happen in tornadoes. The higher the wind gets, the more this happens. And, for instance, in my book, I talk about the Joplin tornado 2011. There were boards driven into concrete without being broken. I just can't fathom how that could happen. But just amazing things that happen when you crank the wind up to 250 miles an hour.
Well, I'm just trying to figure out mentally if like something like a trout-nado could actually happen instead of a shark-nado, just something hits a pond and sucks up some. Because you hear about like it raining frogs, and that's because something has shot them into the air. There's been documented evidence of that because like a little waterspout did that. So I'm just trying to think, where are they getting all this crazy information? Because there are people in this world who watch that show and think it's not fake.
Well, anything's possible. If you had a strong enough tornado over water, let's say it was a tornado watch in effect, there was a big dip in the jet stream, you had that wind shear that we talked about that you need, you got a large tornado forming over the water, of course it's technically called a water spout, as long as it's over water, and it picked up some sharks and fish, you could do that, and then move ashore and dump them on land. Okay. Yeah, that's possible, and fish falling from the sky, I've actually heard of that. Frogs, anything that can be picked up can be dropped. So, yes, that certainly is possible. I think that anything like that's going to be horribly exaggerated in a movie. I saw a movie called Magnetic Tornado. It was hilarious. The special effects actually were pretty decent on that. And that was a tornado that was produced by some weird magnetic experiment that went wrong. And, of course, it's picking up all this metal and throwing it everywhere. It's crazy. But, yeah, pretty much anything's on the table when you get winds that strong. Like we talked about the 10-ton storage tank. Throwing a half mile, I can't imagine that.
No, I couldn't.
Fish, sharks, they're all available for our fantasies, and also we have incidences of fish coming from the sky and things like that.
Well, let's go from the impractical to the practical. If you live in a tornado area, and quite frankly, the tornado areas have grown. It's not just this tornado alley in the middle of the country. I've heard of tornadoes in New York City, and tornadoes, like you said, Worcester, Massachusetts, places that you wouldn't think would have them, have had tornadoes, isolated incidents, but have had them. So if you're in a tornado, so you're driving along the highway and, which is usually the case when you can't get out of the way of weather because you're kind of going from point A to point B, you cover a couple hundred miles, so you don't really know what the weather's going to be like. Next thing you know, you're just outside of Dallas. It's getting ugly. Now it's tornado time, possibly. In a car, what's the difference between in a car and in a building? Because in a building, I think you have certain places you can go to be safe, but in a car, you're kind of out there.
Yeah, Craig, and that's a good point because, with the technology we have today, the good news is that if we just maintain a connection with the information over a mobile phone, a NOAA weather radio, TV if you're in your house, PC, whatever, you're going to have the information you need to avoid getting trapped in your car in a tornado. Now, let's just say for whatever reason you don't have access to that, your cell phone battery died, your laptop won't work, whatever it is. You see a tornado coming. Hopefully, it's going to be several miles away, and you can stop your car and seek shelter in a permanent structure or drive away from it. It's very unlikely, if you're paying any attention at all, that you're going to be so close to the tornado that you'll have to abandon your car. But if that happens, and you want to get out of the vehicle, you never want to be in a vehicle when a tornado is imminent. Get into a ditch or a low spot, so you're going to get wet, and you're going to probably have an unpleasant day there for your hair and things like that. But your odds of surviving in a last-ditch situation where you have no permanent structure to hide in are better out in the open in a ditch. Now, it's got to be a low spot to work for you than in that vehicle. And a couple of studies to verify this, in Wichita Falls, Texas, April 10, 1979, an EF4 went through there, and there were 42 fatalities. 25 of those people were killed in their cars. It was rush hour traffic. People were stuck in traffic, and this tornado had really good visibility. People could see it coming from miles away because there was no rain wrapping around it. It was just a very visible tornado. You can go on the internet and see lots of great pictures of it coming through. High fatality rate there, high percentage in vehicles. In the El Reno tornado last year of Oklahoma City on May 31st, 2013, I already mentioned the 3 storm chasers that were killed in that, and there were a couple other people that were killed. They basically drove right into it. Okay, it was rain wrapped. They couldn't see it. They didn't even know what they were doing. They just drove into the storm. But they should have been aware there was a really bad storm out there and avoided that. So the best way to avoid getting trapped in your car is to seek shelter in a nearby permanent structure. If that's not available, yes, you'll have to go and get in the ditch there. But I think, again, the bottom line, I talk about this in my book, about being weather aware. If you're expecting storms, if you've heard about, hey, there's a tornado watch, or hey, there's a risk of severe weather that day, it's really your responsibility to try to keep aware of where that is in relation to you. Now, if you have to drive away from a tornado and you have the time to do it, always go at a right angle. So let's say you're going north, tornado's coming from the west, you don't want to turn and go east or even southeast to get out of the path of that thing. You don't want to turn left into the path of it. Okay? Now, if it's behind you, obviously, you want to continue going away from it. So a little common sense there to help you. So you need to know where the tornado is and which direction it's going. You can get this information off any NOAA weather radio, which I encourage everyone to carry one of those on a trip. They're cheap, about $60, which, hey, that's cheap these days, tank of gas. And you get a battery-operated radio. It'll work anywhere. If you don't have access to that or don't want to spend the money, download a cell phone app for $10. You can actually get a cell phone app that'll give you the NOAA weather radio emergency information when it comes out. You can get radar on there. You can know what's going on and not find yourself in the terrible position of driving into a tornado, Craig.
Yeah, and like I said, as a driver instructor for a long time, or defensive driver instructor, one of the big myths that I knew was a myth, so I had to dispel this one, but everyone always thought this, is that if you are out on the road and you happen to be in the path of it and you can't get out of the way, I had people go, well, you want to hide under a bridge or get way up in there in the underpass because you can avoid the tornado because the bridge will protect you. And that is absolutely not true.
That is right. In fact, several scientists from the Storm Prediction Center in Norman, that's the place that issues all the tornado watches and severe thunderstorm watches for the country. I've got some quotes from those guys in my book and a link so you can go watch the YouTube video. This became popular after a 1991 tornado went through Kansas. There was a news crew and some other citizens that were driving out kind of in the open country away from any real cover, and they saw a tornado coming, so they stopped and ran up under the girders of the bridge. They got way up in there where the concrete meets the bridge, and they rode out the tornado in there. And in the video, it gets pretty windy, and then it goes away. A couple things about this video. Number one, they were not in the core of the tornado. They were on the very edge of it, so they didn't get the strongest winds. Number two, it was a very small tornado. This is not an F5 or an EF5. It was probably an EF0, a very small tornado, less than 100 yards wide. But because of that video being circulated, people start thinking, hey, I'll hide under a bridge if a tornado comes. Well, if you've ever walked between two buildings on a windy day, you notice the wind. And the same phenomenon happens if you get up under a bridge. You're getting into a smaller area, so the wind that's coming in there is now compressed into a smaller area, and it accelerates through there. So actually inviting yourself into an area where flying debris or anything that's coming through there is going to be more likely to speed up and hit you at a higher wind speed, which I don't think we want. So don't hide under a bridge. That's a bad place to hide.
Yeah, and my analogy that I used to tell them during the defensive driving class was that consider yourself a dust bunny, and you are hiding underneath your dresser. And a vacuum cleaner would be the tornado. And all you have to do is get a little bit near it, and as you get closer, all of a sudden that dust bunny gets sucked up into it. And that's one of the things that can happen. If that debris is going to get funneled right into you, and you're just going to end up getting killed more likely than survive. So I definitely wanted to bring that one up because I knew that one was a repeat that I heard a lot about, was Underneath That Bridge. So there's so much more. You've got a great book out. And where can people find you and the book?
Well, thanks, Craig. I appreciate that. I really had a lot of fun writing, and I love writing. It's my second book, of course, and I did a lot of research. I want to make sure it was good science, that it wasn't just some opinions that I came up with. So this book is available on Amazon.com. It's available in a paperback for $8.95 or in a Kindle version for just $3.49. I also have it available on Barnes & Noble for the Nook ebooks. And I've got it on Google Play now. We've got it on Smashwords. It's all around. But most folks identify with Amazon, and it's there. And I think you'll really enjoy it. A lot of links in the back. You want to read more if you're into science or weather. You can spend a lot of hours researching different things. I've got one link to a 494-page National Weather Service report on the Joplin tornado. So, there's a lot of stuff in there, and I think you'll enjoy it. It's called Twister Tales, Tales. And I'll not only talk about myths in there, but I do some discussing of the 10 deadliest tornadoes in the U.S. and some of these freak occurrences we were talking about, like the boards going into the concrete and the 10-ton tank being thrown a half mile. So there's a lot of little interesting oddities and freak occurrences and some stories of good and bad luck that people had in these things, too. And it's all part of what tornadoes have to offer, and we need to respect these things. They are interesting, and for storm chasers, they can even be fun to interact with and chase from a safe distance, but they're also deadly. And I want folks to realize that we're not playing around here. The tornadoes are bad news.
And when can we watch your weather report?
Well, if you're in the Texoma area, North Texas, Southern Oklahoma, I'm on at 5, 6, 9, and 10 every night. And, of course, we have a webcast, so you can watch me anywhere in the country from our website, which is kxii.com/weather. We've got a personal webpage, too, stevelanore.com, and that's a place where you can go and read about the book. And it's a pretty low-tech website, but at least it gets the book out there on a different venue also.
Well, I wanted to make sure that they knew that you were a primetime meteorologist and not some of this weekend, 4 a.m. guy. You're the one that's actually out there when the winds hit the fan, so to speak.
It's funny you mention that because I worked several years in San Antonio as the morning weather guy. And you talk about sheer torture for a night owl like me. That's a long time. But, I'm the chief meteorologist. I've been here in this market for 8 years, and I plan on staying here. The weather here is extremely challenging. We get tornadoes, and we get the wicked winter storms, and we have mountains in part of our viewing area, so they can get snow up there while it rains 50 miles away. And let me tell you something. I keep my hair short for a reason, because those forecasts make you pull it out. They're tough.
And I keep mine short because I'm going bald. But thanks a lot, Steve. That's the show. Thanks again to Steve for coming by. Don't miss his free book preview on the free podcast app. Just look up Reality Check with Craig Price to find it. Email Craig at Speaker Craig Price with questions or comments, guest suggestions, and don't forget to sign up for the newsletter at realitycheckpodcast.com. We'll see you next week.